Hi, this is Team ERCS presenting for the Verizon Challenge. There are 233 million licensed drivers in the US, so vehicle safety is especially important. According to data from the NHTSA, fatal crashes are an increasing trend each year, so we must find ways to address it. Accidents can cause road closures, so GPS apps like Google Maps and Apple Maps use large data sets to avoid such roads and find the optimal path for the driver. And car radio hosts will mention nearby accidents to alert drivers of the issue. Then there are radar sensors that can detect nearby obstacles, which is useful for parking, but none of them can actually predict an accident before it happens. So, because current solutions are unable to, our proposal focuses on preventing accidents before they happen. We use 5G to track other moving objects within a 10-meter radius, and using that data, we can determine the trajectory of the other objects and express it as a polynomial function of time. From there, we calculate the intersection between the two polynomials and determine if the intersection will occur within 5 seconds, and if so, to alert the driver. It will also plot the intersection point on a digital map. And we address low latency communication by selecting a smaller range surrounding the car, which will reduce lag. For individuals without a display on their screen, the map will not show, but the program will still function and alert the user without it. We used OpenStreetMap, an open source map, to make our map. We tested our program on sample cars, so in this case, we used a car and a bike to determine their intersection. We stored their individual speeds for timestamps to determine the polynomial function of each of their speeds. We used a reference line for plotting the points using their position. This is our demo alert. It shows a red exclamation point when the intersection point at a time within 5 seconds is calculated for the driver to react in time. And this is a sample of the car data for an individual timestamp. We used multiple sample data at different timestamps to generate our polynomial functions of time. We store the speed and the xy coordinates to determine the polynomials. We programmed in Python and used PyCharm and GitHub to collaborate. SciPy is a Python library for technical computing, and we used it to implement our prediction algorithm. We used fourth-degree polynomials to represent their movement and predict their trajectories. We used OpenStreetMap to get data for our maps, and then Map Machine to render the data and display the vehicles. We intend for our product to be used by car manufacturers. They can install our software into their vehicles to ensure user safety. And our project is scalable because we can develop a mobile application in the future for people whose cars don't have the feature. And these are our references. Thank you!